these. Okay. Yeah, there you go. Nice job. Thank you. Testing, testing, testing. Maybe a little higher. That's probably pretty good. That's good. All right. Can you hear me? All right. We got a good size round today. Do you guys have your computers? Because we are hitting the driving range, and this is going to be a participatory event here. It's vibes, but we are golfing today. Are we ready? Are your clubs clean? Are your terminals clear? Because this is the inaugural talk for development as golf. So if you were with us 2 weeks ago, I gave a talk, Mermaids and Sculptors, which kind of perused the space of how I've been thinking about making long shots and trying to develop in a way which is establishing a new theory of mind around how to use LLMs to achieve goals, mostly in the space of software development. And I'm finding a lot of the language around how we think about certain aspects of these different heuristics which folks have been sharing between one another about how to approach development from the perspective of the repeated procedural and automated use of LLMs as lacking. So here, my aim with this talk is to introduce the idea of hyperdimensional space golf in a way that allows us to extend the overall the overall ontology for how we can describe going from one state in the development of application to the next, and that is hyperdimensional space golf. So if you'll heed me, it's vector space golf for that matter. So what we're seeking to do is to achieve learning a little bit about how reinforcement learning with human feedback works, how we got here canonically in the grand scheme of things of having now LLMs, which are trained on all written down human knowledge, how vector multiplication has resulted in seemingly extractable and useful intelligence in the form of prompting and transformation of intent and higher order logistical resolution from just figuring out how our own semantic exchanges work with language to then a higher order language model and inference set. Colloquially, transformers have been able to unlock this potential to essentially build things with semantic language. So I think we should start just as a ensemble as a party, as a genius, the collective genius of the whole, starting to build a new ontology for how we describe working with this inconceivable entity, the embedding space. And so I've tried here to pull out this idea of this embedding space, this massive entity, if it were real, something that is, space-like, it's hyperdimensional. We can barely even raster the actual spatial elements of how these vectors, which are ultimately spatial entities, are actually composed and how they take ideas and turn them into raw numbers. So that's the mechanics of what I'm going to sneak in here a lesson of through the really this idea of golf as a lesson. So the moding motif is that cover art, essentially this gigantic entity. And we have well, here recapitulated, the prompt which I used to make that, but this idea of the developer needs to navigate semantic space. The models are ultimately trained on human knowledge and intelligence as it has been distilled by language. That represents your own knowledge, which is very much tied to your experiential evidence in life. And so going back to this, I'm urging all of you to think about and even try to have a Fermi calculation of how many pages you have read in your life of, any type of text at some type of human readable level. And I want you to imagine yourself standing on top of those piles of books. And that's a growing stage at any point. And that as an imaginary basis is actually all of the context of reading that you've ever done that is actually your own trained model to be able to chat with this entity. And what I find is, many people have similar sets, and we can run diffs on the, how much one person has read versus how much different stuff people have read and how much canonically similar things I've read, i.e. like, the required book in your high school. That set of knowledge, that language, we're gonna call that our T. And essentially we are, as human developers, constrained by how high we stand on this pile of books, how much you have read. It's kind of it's a very levelizing factor as far as how much effort one has put in. It's probably consistent throughout, IQ, although it is probably also correlated with IQ about how much you've read, but it is equivocating in that you can read more and be able to do more in LLM space by knowing more words, how they work, and how to wrangle and take shots into LLM space. So just want to be, this is our training session here, so I want to be, pretty cognizant of time as we go through this. And the main thing is to keep this talk fun and actionable. And so we are going to build a simple e-commerce app. And we are going to think about our club selection like we would if we were to go out and play some golf on a golf course we've never played. And so we want to think about going on this cliff edge, but really grounding ourselves on a golf course, a beautiful place, an aesthetic feeling that's familiar. And we are truly working in this idea of the real value of the embedding space. So this is what we're working with. We're working with our clubs. These are our heuristics for how we might think about prompting. We're going to have precision clubs, close clubs, a driver, a wedge, a hybrid, a putter. These are going to help us in different scenarios, and we're going to think about how, when we get a response from an LLM, particularly in code, and how we understand those responses, what club to choose versus our own understanding of our goal. And as with development, setting that goal post is half the battle. And we are also going to use this to extend the analogy to be able to not only review the quality of our prompts and how close those have gotten us to our goal, but also to develop the framework of future courses which we may design ourselves and think about to segment intermediary steps in developing very large projects. So without further ado, the shot archetypes. First, and almost incrementally, and one of the impetuses what I've seen for this talk is that most people with LLMs know how to use the putter very well. And most people actually show up to the tee with the putter. They forget to really think about using executive language. That is giving the model the agency to contemplate certain apps of what they want to build, to expand the space of potentiality, to take bigger shots, to try to achieve bigger goals. Moreover, but the more often problem is I see people, if they do take the driver, they go for these one-shot drives. They often bring the putter with them to the middle of the field or even in the rough, and they get overfixed on localized entities before going and making further leaps. And I challenge even the best prompters out there to truly not get over concerned with the roughness of some of the details of your outputs as you begin to develop apps where you utilizing these respective models, which are developing the ontology, the semantic basis for your new repository or any project you're developing on, to take larger shots and put away the putter till you'll need it. But we want to introduce as a putter as, very localized changes within semantic space. And to use LLMs in a way which I've been successful with is we want to use some bigger clubs. And so that brings us to the driver. And if you will heed me, we could use the putter and the driver the whole way. Now, locally, I think you've all experienced using the driver and the propensity of the LLM to think you might be using the driver when you're trying to do refinement. So thinking clearly about how we might think about using prompts to say, hey, let's actually, just change this color, or like let's put in a little tailwind class to bump that over, versus, let's just fully blow out the entire e-commerce plan and app in one shot, right? So those are obviously very different prompts, and I think we are ontologically, as a genius, as a collective group of people learning to work with these machines, lacking the analogies and bases by which we are thinking about framing our prompts, from other than just how we describe those prompts, but from a qualia of the experience of actually working with LLMs and getting responses back. So those are our two ends. We have the precision work being done with the putter, and we have the long shot work being done with the driver. Then we have what is the iron, and this is a little bit muddier with respect to this theory, but these are any long shot prompts where we want to think about this tool different than the magnitude of change which are expected specifically from the putter. The iron is going to make our longest leaps. The iron's creating most of the value in our creation. This is between the 5 and 40 prompts that are well crafted within the semantic space of what you're establishing, and those are actually making the long leaps where you must maintain both strength and accuracy in your shots. And that is where I also see, in the canonicalization of this talk and thinking about these tools, many people not quite grab this idea of the use of the iron and planning steps. So I think an iron should be used from a well-purposed set of planning. You have gone off the tee and you have evaluated what you got. You might have ended up in a hazard. It might have not made it all of what you wanted. You might have been right down the fairway, and you have what seems like 99% of what you asked for in that app. The iron is something that where you have done contemplations prior, i.e. the making of markdown files or whatever, it is then taking in that respective context, planning your shot, and then lining up that drive towards your goal. And the iron also is the tool by which you move your goal. This is where you also introduce new information and set the actual putting green out further. And so this is where we're actually expanding the field of the course that we're playing in. The wedge. Now, the wedge is a tool used for steering. It's one which you work with in the wind. This is where most of us start to think about, and where I spend most of my times with LLMs and have very often admittedly become the most lazy. It's the let's copy the output of the logs and copy and paste that into the LLM and say fix this. It's a dangerous shot, because very easily in the flow, if you ever experience playing actual golf and you're close to where you want to go, you could, where you might have otherwise taken a putter, taken simple steps, understood the problem, and addressed particular aspects and worked in detail, tried to get to that end too fast, and you end up just hitting the shot and slicing it, and the ball goes far past your goal, and now you're off into the woods, and you have to revert, if you are even prepared to do so in that first place. So the idea of the wedge is, it's a club that we don't want to have to use. We really want to, in an ideal case, in our par case, we would drive, we would sequence our set of irons and get to, a local area where then we can do refinements with our putter. But the wedges often need us to get out of cases, and as the user, your case is often where you're developing really fast, where you have a onslaught of information from these LLMs, working faster than they ever have before, where you need to update with the actual semantic model of what are the things called in your code base. The wedge is that tool where you are in the rut, you are reading the code for the first time, and you are starting to actually frame these different tools. That might be building the observability dashboard. That might be filling in these respective logics. It's the artisanal work to kind of apply what we know as developers in the kind of yesteryear working style of software development to pull out what tricks that we have and get back to approaching the green and working towards our goal. Now, in many cases, we have gotten to the point where the wedge no longer works. And so this is when we're going to have to use our recovery shot. And this looks like actually a well-preparedness, which this might require you actually needing to bring a number of tools with you before you venture out. And so what that might look like are your set of ball recovery tools. And this is a very kind of fun area of contemplation for inventing real golf tools, little extra things. As I golf caddied back in the day, and it was always fun to see these like contraptions that folks would bring along with them to kind of solve their like water hazard problem, or like in the rough or in the poison ivy problem. And I think this is a very similar problem where in the exchange of ideas we can build our own water hazard tools. And what I'm bringing here today, specifically with these, how they differentiate from the rest of them, is this is our tooling that we set up before we go out and play the course, before we start coding. This is our Git work trees. This is our pre-commit hooks. These are our tools that we bring from experience, from having worked with these tools, that give us guardrails, that give us protection, that allows us to actually recover where we are at and continue to make progress. And so these are bits and bobs. These are learnings. These are scripts. These are tools which we can automate and use to help us get out of sticky situations. Next we have the chip, and the chip is different from the wedge because this is about really gauging and using words that are, when we are scoping these example problems, these are words which are more computer science aligned. This is, I'm kind of forced to kind of differentiate by using this ontology, but I think I've discovered a particular difference between the wedge, which is kind of saving us from these wayward directions, the iron, and the chip. And the chip, what I have discovered is the specific aspect of the chip is that, and this is not exactly the right canonicalization, but the chip is really close work, and this is where we're actually referencing entities as they're in the code base directly as we have discovered them, and being extremely clear about how we are executing, and using the verbiage of computer science, not just of creating directives and plans, to actually constrain the model to actually edit a string, or actually create some type of 8-bit array stream, or work with an interface. This is where the knowledge of software engineers really comes in advantage, and where having the software engineering background, or the explainability of the experience of a software engineer, which is really important here, that's where the difference between the kind of vibe coder and the software engineer really comes into handy, because this is where your experience in solving problems before, talking about specific computer science problems, the definitions for how we learn to approach those problems, and then preparing how you would traditionally to make an edit, finding the entry points, writing out the logic, and then building the exact, almost code-like prompt to then execute that respective change. And that's the chip, and that's really where the art of the game is. Then we have the curve shot. And if you joined me for the last talk, this is actually a kind of side canonicalization of what I call Big Brother programming. But this is where you build a workspace, and you have wins. And so the wins are other courses that influence your development pipeline. So this is bringing in example code that will steer the embedding space of your actual output. So you want to think about other code base as deviating the path of what was otherwise your drive, your web shot, using those respective constraints. And this might actually involve constraints. If you're building 3D tools, there's many pathways to build tools where when you start to introduce, say, WebGL or 3JS or React 3 Fiber. These are very large packages which are very opinionated, which are actually going to add a lot of weight to your context model. And so you need to be thinking about curving your shot with the winds of what exists in the context of those dependencies which you're building. The drop. This is a good old revert. And it's very often the case that the drop is also something which can happen, and which differentiates this particularly from the recovery, is the drop might happen where you're actually taking some type of newly developed solution, so i.e. going to a new code base entirely, or going and doing a prototype in some type of prompt to app, and then using that as a vector to then resituate your drives inside of the code base. And so this idea of going back to the initial concept and then taking a new direction, bringing that new direction in as like new seed data from where you can then really drop a position and then reapproach your goal, but within the to not lose that entire prompt context. And there's a relationship with respect to how we think about Git and how we think about using trees, branches, and other aspects of revision work, and revision work that gets us closer or further from our goal is the idea of reusing work that went bad can be a part of this, and having an LLM look up a Git diff and then have that be as part of a sequence of getting regular expressions that are then indicative of how you might want to make a change. You can use the explanation of how your initial drives went poorly to then revert and restart. And I think this is a very underappreciated method of taking many wayward drives, using that semantic base to then return to not only the deck, the original point, but somewhere at the intersection of those initial drives and having a drop start between different projects. And those projects can look very different. The layup. So this is where we have potential hazards in the way, and we want to often build our own tool from the ground up. So my own experiences with this hazard are that we are often working with, this one doesn't have scrolling in it, but The layup is, making it easier to take our next shot. So you might say, oh, we are going to have a content-rich app. When using prompt-to-app tools, which applications are very often perused, which is having a lot of pictures and having a lot of high-res pictures and making an S3 bucket and shipping those all in. Little does the uninformed developer know that they are about to be in for a giant bill from Amazon, provided that folks use their app. Other people have kind of solved this problem, but if it's your first time developing an app, you're not going to quite know about using next image or using a script to segment the size of the actual required pixels for the least contentful paint. So we want to think about hazards of these elements, which are both aspects of our future development as things we want to prepare for, and we want to play short of the hazard often. So thinking about in the usage of our driver or of our iron or even our chip, we want to play right before the hazard and then kind of peruse very carefully towards these edges where there are actually these true cliff failure hazards. And I'm sure as software engineers you have, or anyone that has built something, know risks and hazards, and LLMs have common pitfalls, such as delivering full-size images at scale. And so we can think about defining those hazards as we go about planning. And then finally, the punch shot. I just basically kind of this is a useful canonicalization of where you would otherwise use an iron, a driver, and a putter, and trying to get to your goal. I often find it useful to go right towards your goal from the drive as soon as you can, like being very declarative, being lazy, and punching right at the pin with the hopes that provided you're lucky that day, that you can take a low iron shot and you will hit the pin and it will go right in the hole. I think the heuristic here is that golf can teach us a lot more about LLMs than LLMs can teach us about golf. And it's very often the case that, you know, you can get really lucky. You hitting the pin and going right in these days is kind of more often, I see it happen a lot more often, where I'm thinking about these incremental strategies and I'm planning out all of my step-by-step iron shots, my web shots and wedge shots, and then I'm thinking about cleaning the app up, where, you know, sometimes I just load it with context and I take a full power punch shot right at my goal, and if I don't get there right away, there's something I can learn from that even superficial implementation of, like, you know, I've been like, hey, like, you know, build me an entire physics engine for, making a protein battery from scratch. And that type of prompt actually, even superficially, gets towards this local minima goal space where the model's forced to, like, think through maybe a suboptimal path, but in that experiment, you might find and learn a ton of what you've never even experienced before, especially when you're in a new space. And so the punch shot is both a research tool and kind of like a gamble towards winning, and it's becoming cheaper and cheaper to make these punch shots respectively. Although the kind of caveat to that is that you might kind of burn out on an idea by, like, building, you know, giant prompts and expecting a win, and then getting to this, like, superficial local minimum that is not well planned out. But because the apparent nature of that superficial minimum looks and maybe even feels like what you were thinking about, it's like a faux pas that you want to really be mindful of, that you are truly, when, you know, going for these, like, you know, instantiate the project and then try to get to your final destination by just iterating on what came from that initial response. That this is like a faux pas approach, but there is value in the extraction of what was actually generated in that step. So yeah, this decision tree is certainly going to grow. You know, thinking about how we reflect on what we got back from the respective LLM with a given prompt. We want to think about, you know, our initial prompts, and part of what I want to introduce today is another canonicalization of what's the semantic certainty of your application. So if you hold on a moment, I could kind of just explain it, but. So when you first set your prompt, you are taking kind of infinity, all of the respective potential things you could build, and collapsing it by I don't know how many 99.999s. So this idea that, you know, you're showing up, and those initial prompts really matter in establishing your progress for that day. And so I really I advise using your driver a lot, going to the range and practicing building prompts that get you closer to your goal faster, that aren't wayward, and you learn what is semantically acceptable in working with LLMs. The caveat here, as discussed widely, is that the kind of central vector of the way that the LLMs are trained is this TypeScript, React, Next.js stack that kind of all look the same. And so being very specific about how you diverge from that, like, trained means of the bias of the app is important. And you need practice to be able to describe what are the caveats that are important to distinguish, where is the model going to fill in details that you otherwise wouldn't have expected it to, and how you can take better drives that don't kind of curl off into the rough, requiring you to save yourself from local minima. Yeah.
That are outside of the distribution of common apps. I think that's the question.
Yeah. So if you need to create something outside of the distribution of common apps, you need to learn to take big drives that are explorative. You need to get into the woods and kind of learn the ontology there as you would learning a programming language yourself for the first time, and let it kind of just fill in the tokens so that you then build up that semantic base, which is basically learning how to swing a golf club and turn the face and do everything you need to connect the shot together to actually get towards your goals faster. So in kind of output and what I think will be my gift and open source contribution towards developing this model is a development scorecard. And we could switch kind of to the app now. And thinking about, for any given app which we might build, let's say we build a e-commerce MVP, how might we then, build the entire app in a round of golf, in individual features that we play, where we have a target goal, we're able to qualify that goal, and we're able to get one from the next. And then, we literally count prompts. We think about taking shots as, number of prompts that gets us to a product listing, one that gets us to having an implemented cart. So, whether you use the shop API or you build your own, cart from the ground up, it's likely that in the space of both of those tool cases, you can create your own prompts that get you there in under 4 prompts. So that's describing tool usage or describing recapitulating that feature from the ground up. So on that note, we want to think about getting to goals faster so that we can iterate our learning cycles, because a lot of the value comes from getting to the putting green, getting to these local minima, and having the experience of whether or not you were in frustration and actually achieving goals by the structure of your prompts, and using the difference in the spread of data of many different experiments to, one, update your own model of explainability for how to use these tools, and be able to then describe better prompts as you then move your way towards working on bigger projects which have different courses, which you might then use the space of considering how you might approach building big collaborative projects as the design of a golf course. So, this week, pick a feature that you're working on. Write down, how many shots do you think you can get to in that feature? Think about framing it in the respective kind of 4 different types of shots. We want to think about the driver. What is that big prompt, that initial prompt? And it doesn't even have to be bigger. It could be quite simple. That gets us to like 99% of where we're going. And that looks like, center fairway in a real golf scenario. And we're collapsing from this hyperspace to this idea of the many channels, rainbow road of indeterminate length potential golf courses where we could just keep going forever, but we know we want to set the respective post somewhere and get to a goal on this feature and get to a set of requirements that then meet the overall the requirements of the feature that you set out to play in the first place. So count your shots, count your number of prompts. I recommend bigger prompts that have more specificity, that are mapped to the types of tools here. And ideally, to complete this, you would use your driver, get pretty close, and then implement the features as you've kind of structured them out in your plan with your iron, and then putt. Do those last bit of refinements that get the design system in compliance with what you're building. But now you have the tools to think about framing the respective other types of cases and framing those according to actually being cognizant of how much you're prompting something. I think when versus actual coding, where we were able to in software development count lines of code, count kind of the efficiency of our code. There's kind of there's a asymptotic non-linearity to like how much you prompt and how much value you're creating, and we need a framework like this, I believe, to actually track our progress as we prompt, and realize that we are in the water hazard. And in developing this I use this method to develop this talk as well, and in the app that I'm going to demo. And I found myself in the literal feature that is the water hazard, having an underdefined water hazard, which is, I think, very poetic in the formation of the idea of this talk, which is that, you know, the water hazard can be undefined. You might not know that you are in the water hazard. And you might have not read the code. You might even not know where you're going. And so I'm gonna wrap up early, or wrap up on time if you look at it one way or the other, and you know, challenge yourself to find out if you're in the water hazard. And if you are, I recommend building an extra tool for yourself for next time you take a gab at taking a swing in the Hyperdimensional Vector Space Golf course.